Dear students, today I'm going to be on page 102 and 103 in your study guide, and that had to do with the hydrolysis of polysaccharides, proteins and lipids. Now, what is the objective of this is to use special types of media to detect the hydrolytic properties of some of the enzymes that's been excreted by bacteria. Why do they want to excrete enzymes to the outside? It's because these molecules, these starch molecules, these lipid molecules, these protein molecules, they are too big to be taken up by the cell. For that reason, they excrete enzymes to the outside so that it's easier for them to take the smaller molecules up. Alright, and we can illustrate it with experiments that we can do. But let's first go through the overview and see what they say. Some microorganisms produce enzymes capable of splitting large complex molecules of polysaccharides, proteins and lipids. These enzymes are being called extracellular enzymes, being exoenzymes, and accomplish the breakdown of respective substrates via the process of hydrolysis. Polysaccharidases hydrolyze polysaccharides to sugars, and proteases hydrolyze proteins to peptides and amino acids. Lipase hydrolyze lipids to glycerol and fatty acids. When organisms are grown on a medium that contains one of these three substrates, evidence of degradation can be obtained. Alright, and that brings me then, what are we doing? In starch hydrolysis, we're using normally nutrient agar containing starch. In the case of protein hydrolysis, we're using nutrient agar with milk powder. And in the case of lipid hydrolysis, we add tributyrin to the medium. Alright, on page 102, they say evidence of starch hydrolysis. What are we doing? If we've got the nutrient agar plate, the first thing that you will see is the line that we streak in the middle. That is my streaking line. Let me just get my pen here. That is a streaking line, and then after incubation, we will see there's growth. There's growth on the nutrient agar plate. Okay. Then after that, we flood. What is coloring starch blue? It is gram iodine. So we flood the whole plate with gram iodine. In the case where the enzymes is being excreted into the environment, we will find the clear zone, and the rest of the plate will stain blue. The rest of the plate will stain blue, and this clear zone around the organism is an indication for us that the organism can break down starch. Okay, so we're doing exactly the same. We're doing exactly for lipid hydrolysis. In this case, we're using tributyrin into the agar medium as an emulsion, and the medium appears opaque. Hydrolysis of the lipid tributyrin results in its products, glycerol and fatty acids, that are soluble, and hence there is a clearing zone around the growth of the organism. Okay, so in this case, in the case of lipid hydrolysis, we do not put a reagent on it. We just incubate it. And on the line of where we streaked out, we will see on the line, just around the line, we will find growth. But in this case, we do not put any reagent. If we see tomorrow, after incubation, a clear zone around that growth, then we know the organism is capable of hydrolyzed lipids. The same with protein hydrolysis, where we're using nutrient agar plates. We're using nutrient agar plates containing milk powder. And they say it's a nitrogenous constituent of milk. It is a protein. It exists of colloidal state, and as such is responsible for the white color of the plate due to the white color of the milk powder. In the case it hydrolyzes these proteins in the milk, the product of this hydrolysis is soluble, and a clear zone will be we will be able to observe it around the growth of this organism after incubation. So, what is important? The three different types that we testing here in hydrolysis, it's polysaccharides, it's proteins, it's lipids. What is polysaccharides being hydrolyzed to? They've been hydrolyzed to sugars. Proteases is hydrolyzing proteins. To what are they hydrolyzing it? To peptides and amino acids. Lipases hydrolyze lipids to glycerols and fatty acids. What reagent must we put onto the starch plate to illustrate for us the clear zone? Gram iodine. Okay. In the case of lipid hydrolysis and protein hydrolysis, we do not put anything on there. Okay, so now we know how to test for the hydrolysis of polysaccharides, proteins, and lipids. Listen, there's a lot of pictures. If you're going to Google Pics and you put in there starch hydrolysis bacteria, you will find a lot of these pictures of clear zones. Remember that if the organism does not produce that clear zone, we say it is starch negative, lipid hydrolysis negative, protein hydrolysis negative. If we only say it's positive when we can see a clear zone around the organism. You can also YouTube practical on this. There's a lot of practical examples. If you put in there starch hydrolysis bacteria, you will find a lot of YouTubes, and you can see clearly what am I discussing here. Okay, students, God bless you in this lecture.